may be wondering how we can solve problems using a computer. There is a way. We will learn that. In order to use a computer, we have to know how to give the instructions by a computer. Now, can you go to your computer and ask it, or can you tell, do this and do that? We have to learn how to solve a problem using a computer by giving instructions or talking to a computer. We use a certain process called writing algorithms. We have to use an algorithm to solve a problem. What is an algorithm? It is a difficult or different word, but you have to learn what is an algorithm. Its meaning is very simple. In order to do something with a computer, we have to give the computer some instructions. These instructions should be in order, and also by using that we can solve a problem. Remember, we can't solve all the problems in the world by using these algorithms. We have to get certain problems that we can solve using a computer. Remember, if you are asked what is an algorithm, you have to remember we can solve a problem using an algorithm, and it is an ordered set of instructions. These instructions will be given in maybe in a computer programming language or maybe a language familiar to you. So, we will try to write an algorithm. Now, I will give you a simple question. Suppose you have to add two numbers using a computer. You have to add two numbers. When we add two numbers, we can get the total of those numbers. So, now remember, in our last lesson, we learned input, process and output. Now, those are the steps we are going to use. First step is we have to identify what are the inputs. So, our inputs are the two numbers. So, first we have to input two numbers. Then, we have to add them together. That is the process. Add them together, and also we have to have some value as the total. So, I have written add them together and assign to total. First we input the two numbers, then afterwards our addition is assigned to total. Now we will get the output, which is the total. This we can display the total. Now analyze this problem. Now this is an algorithm. We have simple instructions. These are in order. We have to, as our first instruction, we have to give the input two numbers. Then next we have to add them together. As the last instruction, we have to tell the computer, now you have my addition, please display the total. We can write it in different ways. I will show you another example for this same problem. We can input two numbers. We can say N1 and N2. We can say input two numbers as N1 or N2. In our previous problem, we used input two numbers. Or you can specify, I am using one number is N1, the other number is N2. Then also if we have to add them together, we have to give process, which is add them together, and we store that value in total. So we ask the computer to store my addition of N1 and N2 in total and display it in total. Now these two are examples for algorithm. Remember, we have to give very simple instructions and they have to be in order, because computer is a machine, it cannot think. We have to give every instruction in order. Now, suppose you are going to calculate a person's age. How will we do that? think, what are the inputs? We have to input year of birth, and also computer doesn't know the current year. So we have to give the current year to the computer. Then we have to tell the computer the way we calculate someone's age. So we have to say calculate age by subtracting year of birth from current year. You have to give the way to do that. So this is the process. Then we can say display age. Now this age is in years. So this is also an algorithm to find the age of a person. In the exam, you will be given simple problems like this. You have to identify inputs, processors and output and write the algorithm. These can be written in very simple language. Now, suppose you are going to write certain programs. There are certain structures to be used. We call that as control structures. Control structures, that is, we are going to find how the program flows. In some problems, we only have to do certain things in step by step. They are called as sequence, step by step. There are mainly three structures: sequence, selection and repetition. Sequence is step by step. Selection is, sometimes we have to find some things using certain criteria. And also there will be problems where you have to do a task several times. So we have to learn three control structures. They are sequence, selection and repetition. First, we will look an example for control structure sequence. Now look at the diagram. You can see there's a flower pot. You have to take a flower pot. Then you have to put some soil in the flower pot. You have to put some seeds and to the soil, and you have to add some water. Then after some time, there will be you have to keep it in the sunlight. After some time, there will be a tiny plant, and after some time you will have a plant with some flowers. So analyze these steps. First, the order is very important. You can't just have a flower pot with a flowering plant just at the beginning. We have to take a flower pot, then we have to add some soil, and also we have to put some seeds, then water, and also we have to keep it in the sunlight. So likewise, we have to give the steps in order. If your problem is like this, step by step, we call the control structure as the sequence. In your problems, you may be asked to identify the control structure. So read the question carefully and find first step, second step, third step. Identify the flow. If it goes step by step, we call it as sequence. Okay. Now think about the instances where we use this structure. Now year by year you go to grade 10, grade 11. So this is an example for control structure sequence. Now we will move on to the next structure, that is selection. No, we will first analyze an example for this control structure. Earlier I described you how to take the total of two numbers. We will use this example for that. First of all, we have to input two numbers, then add them together and assign to total. Afterwards, we will display total. So this is an example for the control structure sequence. All these happenings are step by step. You can't change the order. First you have to input the two numbers, then only you can add them, then only you can display the total. So try to find out examples during these days for these kind of problems. Now we will move on to the next one, that is selection. Now these days you have so many instances or examples for selection. Now recently we know Americans, they chose their president. So they voted, they had to select there were two candidates, they have to select. So they have to have a choice, they had to select one over the other. So in these kind of questions we have the control structure selection, or there may be a branching selection. So we will look for an example in that selection. Now it is also, if you have to enter two numbers and decide which one is the larger number, then there you have to select what is the large number. There you have to use this selection. First you have to input two numbers, then what can you do? You have to compare the two numbers and find what is the larger number. Then you can display the largest number. If you have two numbers, you have to check. Suppose you have entered 20 and 35, you have to check which is the larger and display the largest. The same control structure is the only different one. First you have to input the numbers, then you have to compare them and then display the largest number. So remember, when you write these steps, use simple sentences and write the arithmetic operation or write the process you do to in order to get the answer. Now here I have used the word compare, but you have to identify how I can compare them and give that to computer. Otherwise computer can't understand these words. We are just here writing the algorithms, the way of doing things. So our last control structure is repetition. Now here look at the diagram. What is this person doing? He is painting a wall. So this kind of an action, he has to do it again and again until he has painted. If he has to paint a wall, he has to do that painting again and again till he has finished painting the wall, or maybe till his bucket is empty, he has to do that. So these kind of actions we will do. If we have a math problem, we will do it again and again until we get the correct answer. You can think of so many problems like that. We will look at an example. Here I will use this example. Suppose you have to enter a number and guess whether it is an odd number or an even number. So we input a number, that is our input. Then we are going to find whether it is an odd number or an even number. Now you have to think the process of that. I am writing algorithms. I am just stating what the action I have to do. Find whether it is odd or even. Then we have to display whether the number is odd or even. Then but if we are doing this, we know now my number is, I have entered the number, I have displayed the message, and now I have to stop. But in a computer doesn't understand when to stop. So in these repetition structures, we have to tell the computer when to stop. It is very important. If not, computer would do that task repeatedly, and you know the machine, it won't get tired, it will get stuck. So we have to tell, when I enter this number, you have to stop that. So in order to do that, here I am going to tell the computer, when I enter -1, you have to stop this. I will give so many numbers, I will input one number and ask the computer whether it is odd or even. Then I will enter another number, it will do the same. But when I enter -1, stop it. So in repetition structures, we have to remember, we have to have input, process, output, and also we have to tell when to stop, when to terminate. So I hope today you have learned what is an algorithm, and also there are three ways to use algorithms. The flow control, they are sequence, selection and repetition, and we have learned examples for these control structures. Okay, until we meet again, remember the lessons we have learned. Thank you.